Welcome to This Explainer. I am so thrilled you're here with us because today we are unpacking one of the most powerful and dramatic forces on planet Earth. Right now, our oceans are undergoing a massive shift. We're moving away from a neutral state and accelerating straight into what scientists are projecting to be a formidable 2026 to 2027 El Nino event. And this isn't just about weather. It's about a fundamental rewiring of global heat and moisture that literally affects billions of lives.
Okay, let's dive into this. We're going to start with the mechanics of the Great Pacific Slosh, track the upcoming 2026 to 2027 event, see exactly how we watch the ocean, break down those cascading global geographic risks, and finally, look at how we're actually preparing for this huge shift. Part 1. The Great Pacific Slosh. To really wrap your head around an El Nino, you kind of have to think of the Pacific Ocean as a massive heat engine, or honestly, just a giant bathtub. Under normal conditions, we have these incredibly strong trade winds blowing east to west. They act like a fan blowing right across the surface of the water, literally pushing sun-warmed surface water toward Indonesia. It piles up so much that sea levels in the west are actually 18 to 24 inches higher than in the east. It's essentially a slanted tub. But every few years, during an El Nino, those trade winds falter, they weaken. And when that wind stops holding the water back, well, the slanted tub levels out. That massive, towering pile of warm water violently sloshes back eastward towards South America, carried by these massive underwater ripples we call Kelvin waves.
So, the crucial point is what happens beneath the waves to the thermocline. Now, the thermocline is this invisible boundary separating all of that warm surface water from the freezing, nutrient-rich deep sea below it. Normally, it's tilted up near South America, which allows cold water to easily upwell right to the surface. But when that warm water sloshes east during El Nino, it acts like a giant, heavy lid. It flattens the thermocline and just crushes it downward. All that cold, nutrient-rich water gets trapped deep below. So we're not just talking about a change in temperature here. It utterly transforms the entire marine environment.
And that single shift kicks off a spectacular domino effect, known as the ENSO feedback loop. It's like a fast-paced tectonic play. When those trade winds weaken, that warm water is free to slosh east, which instantly chokes off the upwelling in the East Pacific. And because that warm water heats the air right above it, massive storm clouds start to form, shifting the entire tropical rain pattern eastward. A simple change in wind literally rewires global weather.
Part 2. Tracking the 2026-2027 event.
Let's move to and see how this builds, because this isn't just theory anymore. As of July 2026, scientists have issued an urgent alert based on live, rapidly developing oceanic data. But to really get it, we got to look at history. Mild events happen all the time, but history is defined by super El Niños. We saw it in 1982 to 1983, which was the first time we caught it on satellite. We saw it in 1997 to 1998, a devastating event with a staggering $36 billion global economic impact. And we saw it in 2015 to 2016, bringing unprecedented coral bleaching. Now we're looking at the 2026 to 2027 projection, and what scientists are seeing in the water right now suggests this is going to join the ranks of these extremely rare, powerful super events.
And the key metric driving this alert, a temperature anomaly of plus 1.5 degrees Celsius. Right now, water temperatures in the crucial Niño 3.4 monitoring region of the Pacific are already 1.5 degrees warmer than average, and both dynamical physics models and historical statistical models completely agree on this. This anomaly is projected to surpass 2.0 degrees by December 2026, which officially makes it a strong to very strong event.
Part 3. How we watch the ocean.
Tracking these massive subsurface Kelvin waves takes some of the coolest, most advanced technology on the planet. Predicting an El Nino requires a globally distributed, high-tech network. We've got weather satellites up in orbit using radar altimetry to measure the exact height of the sea surface down to a fraction of an inch. Because remember, warm water expands and actually creates small hills in the ocean. Then we have the Towel Buoy Array, which is this vast network of about 70 massive buoys physically moored to the equatorial ocean floor, beaming back real-time wind and temperature data. And finally, we have the Argo floats.
Now, what's really interesting about this slide is the crown jewels of this network, the Argo floats. These are free-drifting robotic cylinders just roaming the global oceans. Every 10 days, they sink down to a depth of 2,000 meters. That is incredibly deep. As they go down, they meticulously measure temperature and salinity, then rise back up and ping all that data to a satellite. They're basically our robotic sentinels, and right now, they are watching this massive pool of warm water migrate east. Part 4. Cascading Global Geographic Risks.
Because when the ocean sloshes, socioeconomic and geographic dominoes start falling across the entire globe. Let's start right at the epicenter, the coast of South America, specifically Peru. Remember we talked about that flattened thermocline acting as a cap? Well, that warm water cap stops the deep cold water from rising. Without those deep sea nutrients, the plankton populations absolutely collapse. No plankton means small fish like anchovies die off or flee to cooler waters. And without the anchovies, the entire food web just shatters. Viscerally, predators like sea lions, seals, and marine birds literally face starvation. It is a rapid marine ecosystem collapse.
Meanwhile, thousands of miles away in Southeast Asia, the exact opposite atmospheric extreme takes hold. Because the rainstorms have shifted east, countries like Indonesia face severe, prolonged droughts. These unusually dry conditions trigger massive forest and peatland fires. As we've seen in previous events, these fires release enormous clouds of toxic smoke and haze, blanketing neighboring countries and causing catastrophic public health crises and respiratory emergencies for millions of people.
The global ledger of this single slosh is just incredibly varied. It creates totally disparate crises depending on where you stand. So while Peru and Ecuador are busy clearing river channels and limiting fishing to mitigate flash floods and fishery collapses, Australia is dealing with the exact opposite extreme, severe agricultural drought, forcing them into controlled hazard burns and really strict water management. Meanwhile, across the Indian Ocean, India is preparing for weaker monsoons, threatening their summer crops by distributing drought-tolerant seeds. And over in East Africa, enhanced rainfall means communities are having to elevate housing in floodplains to prepare for river bursts. It's one single oceanic trigger, creating entirely distinct, massive challenges worldwide.
And this brilliantly illustrates the complexity and, frankly, the irony of our climate. Because El Niño is not purely a disaster. It's a global redistribution of heat that actually offers some distinct geographic advantages. For instance, it generates high-altitude westerly winds that create intense wind shear over the Atlantic, literally tearing apart developing storms, which leads to fewer Atlantic hurricanes. In places like California, the shifted rain patterns can actually replenish drought-depleted reservoirs. And in the northern US and Canada, it often brings warmer winters, saving households money on energy bills and reducing carbon emissions from heating plants.
Part 5. Preparing for the shift.
The most important takeaway here is that humanity is not a helpless spectator to the 2026-2027 event. Because our ocean sensors give us months of lead time, we can actually build societal resilience. Organizations like the UN now use what they call anticipatory action, distributing aid, cash, and water purification supplies before the floods even hit. Farmers are adopting climate-smart agriculture, switching over to drought-resistant crops like sorghum way before the soil dries out. Water managers are carefully balancing reservoir levels, and governments are enacting temporary fishing bans to protect stressed marine life. Proactive, local planning absolutely saves lives and protects economies.
But as we look ahead, we do have to acknowledge a sobering reality. This natural cycle is now operating within a warmer world. Global climate change is raising the baseline, making El Niño's heat waves hotter and its rainstorms far more intense. So I want to leave you with this to consider. As global temperatures continue to rise, how will our highly interconnected world adapt to the increasingly volatile rhythm of the ocean's great slosh? Thank you so much for joining me on this explainer. Keep asking questions, and I'll see you next time.